Everyone expected a $30,000 Tesla. Musk just shocked the world. Model 2 at $14,999, launching December. But the real game changer? Tesla's killing lithium batteries entirely. They're going all in on aluminum ion, a tech that stores twice the energy at half the cost. Early leaks from Giga Texas show a tiny 53 kilowatt-hour pack hitting 300-plus miles of range. This isn't just undercutting BYD's $12,000 cars, it's rewriting how EVs are built. Can Tesla really mass-produce this? Or is this another Musk promise? Let's dive right in. Let's talk about the elephant in the room. By 2025, BYD isn't just competing with Tesla. They're crushing them in sales volume. While Tesla perfected premium models, BYD flooded markets with EVs starting at $12,000. That's not a typo. $12,000 for a fully electric car. Musk watched his market share erode in real time, especially in China, where Tesla once dominated. The original Model 2 plan? A $30,000 compact EV. Sounds reasonable until you realize that's still 150% more expensive than BYD's entry models. Who's buying a $30,000 Tesla when a $12,000 BYD does the job? The $14,999 price tag isn't ambitious, it's survival. Here's where things get interesting. Tesla could have just stripped down a Model 3, slapped a lower price on it, and called it a day. They didn't. The Model 2 is a complete redesign. Smaller hatchback body, totally new front-end styling with sharper, higher-positioned headlights that look more aggressive than the Model Y. No light bar across the front, like the Cybercab. Instead, they went for a cleaner, more aerodynamic design that screams efficiency. The body uses Tesla's next-generation Giga casting, meaning fewer seams, almost no panel gaps, and a structure that's both lighter and stronger. This isn't a cheap car trying to look expensive. It's a future-focused design that happens to cost less. But let's address the cuts, because they're real. Fabric seats instead of vegan leather. No seat heating. No panoramic glass roof. Single-layer acoustic glass means you'll hear more road noise. Ambient lighting is basic single color. The sound system is stripped down. If you're expecting Model Y luxury, you'll be disappointed. Musk himself said it. If you want premium, buy a different model. The Model 2 is optimized for one thing, getting as many people into a Tesla as possible. Does that strategy work? Well, even the pricier Model Y sold well in China, despite tough competition. Now imagine a Tesla at one-third that price. Demand could be absolutely explosive. This is where Tesla either becomes a legend or faces massive embarrassment. Every Tesla ever built runs on lithium-based batteries, NCA, NMC, LFP, all variations of the same core element. But lithium has problems. Prices swing wildly. Musk has publicly complained about supply chain chaos. And here's the brutal truth. Even with cheap LFP chemistry, you can't build a $14,999 EV and make money. The battery alone would eat up too much of the cost. So Tesla is reportedly doing something no major automaker has done. Ditching lithium entirely for aluminum-ion technology. Why aluminum? Let's break down the science without the jargon. Lithium ions carry a single positive charge. Aluminum ions carry 3. That means each aluminum ion moves 3 times more electrons, creating faster energy transfer and higher efficiency. Early prototypes show aluminum-ion batteries hitting 500 watt-hours per kilogram, double the 250 watt-hours per kilogram of current lithium cells. Translation? You get twice the energy at the same weight. For a compact car like the Model 2, that's a perfect match. But here's the kicker. Tesla allegedly shrunk the battery pack to just 53 kilowatt-hours, tiny compared to the Model 3's 60 to 75 kilowatt-hour packs. Yet leaks suggest the Model 2 still delivers over 300 miles of range. How is that possible? Superior energy density and ruthless efficiency optimization. The car is smaller, lighter, and designed from the ground up to squeeze every mile out of every kilowatt-hour. Tesla will offer two versions, the base model with 300-plus miles and a long-range variant pushing even further for buyers who prioritize distance over frequent charging. Now, cost. An aluminum-ion pack is estimated to cost around $2,000, less than an equivalent LFP pack. Why? Abundance. Aluminum makes up roughly 8.2% of Earth's crust. Lithium? Just 0.006% to 0.009%. That's 800 to 1,200 times more plentiful. You can verify these numbers yourself. Google it. Ask ChatGPT. Check geological databases. They all say the same thing. More supply means stable pricing and lower costs. For Tesla, that's the difference between breaking even and actually making profit on a $15,000 car. But let's pump the brakes for a second. Aluminum-ion batteries aren't new in labs. They've been researched for years. The problem has always been commercialization. Can Tesla really mass-produce these at scale by December? That's the billion-dollar question. If they pull it off, they just leapfrogged the entire industry. If they don't, this becomes another full self-driving next-year moment. Tesla's approach with the Model 2 reveals something critical about their strategy. They're not making a budget car. They're making a future car that happens to be affordable. The body is seamless thanks to integrated gigacasting, a manufacturing process that reduces complexity and improves structural integrity. The curves are minimized not because Tesla got lazy, but because simplicity enhances aerodynamics and reduces production costs. Every design choice serves dual purposes: aesthetics and efficiency. There was debate about whether the Model 2 would get falcon wing doors like the Model X or some futuristic opening mechanism like the Cybercab. Nope. Tesla went with conventional four-door layout, but optimized the hinges, gaps, and opening angles for everyday use. Why? Because falcon wings are cool for tech demos, but terrible for mass-market practicality. They're expensive, complicated, and require extra clearance space. For a car aimed at everyday buyers, normal doors just make sense. One feature Tesla absolutely kept: full self-driving hardware. The front-facing camera suite is integrated into the fascia, maintaining Tesla's autonomous capability across the entire lineup. This isn't just about user experience today, it's about Tesla's long-term vision. The Model 2 is designed to eventually join the robotaxi network. Musk has repeatedly said autonomous ride-sharing is Tesla's ultimate endgame. Why would they strip that capability from their highest volume vehicle? Let's zoom out. This isn't just about Tesla versus BYD anymore. The Model 2 at $14,999 threatens every budget EV maker globally. Chinese automakers have been eating Tesla's lunch with low-cost models, but they're all using lithium-based batteries. If Tesla cracks aluminum-ion production, they gain a structural cost advantage that's nearly impossible to replicate quickly. Battery chemistry isn't something you copy overnight. It takes years of R&D, testing, and manufacturing refinement. BYD's cheapest models sit around $12,000, but they come with trade-offs in range, charging speed, and technology. The Model 2 offers Tesla's charging network, over-the-air updates, full self-driving capability, and integration with the broader Tesla ecosystem. For just $3,000 more, you're getting a fundamentally different product. That value proposition could swing millions of buyers, especially in markets like Europe, North America, and Southeast Asia, where Tesla's brand still carries weight. But there's another battle Musk is fighting simultaneously, one that could dwarf the car business entirely. Tesla just announced Optimus, their humanoid robot, at a projected $20,000 price point. Musk claims it's the most important product Tesla has ever made. Why? The global labor market is worth 30 times more than the automotive industry. Meanwhile, XPeng unveiled their own robot with fluid movements and hinted at a $10,000 price tag. Tesla has the AI advantage from years of autonomous driving development. XPeng has Chinese manufacturing speed and cost structure. This race is just beginning, and Musk is fighting on two fronts at once. Tesla isn't just launching a cheap car. They're attempting to rewrite the entire cost structure of electric vehicles. If aluminum-ion batteries work at scale, the $14,999 Model 2 isn't the floor. It's the beginning. Suddenly, a $10,000 Tesla doesn't sound impossible. Neither does a robotaxi network that actually pencils out economically. Musk isn't just competing with BYD on price. He's building the infrastructure for a future where car ownership becomes optional. But December is the moment of truth. Can Tesla actually deliver on aluminum-ion production, or is this another overpromise? The leaks look promising, but we've seen Musk miss timelines before. What's different this time is the pressure. Chinese competitors aren't slowing down. XPeng is pushing humanoid robots. BYD keeps flooding markets with affordable EVs. Tesla has to execute, not just announce. What do you think? Will Tesla hit that December launch with aluminum-ion batteries? Or are we looking at delays? Drop your take in the comments below. If this breakdown gave you a clearer picture of what's actually happening with the Model 2, hit that like button. Subscribe to Tech Revolution and turn on notifications so you don't miss our next deep dive into the tech reshaping transportation. The future of mobility just got a whole lot cheaper. Now we wait to see if Tesla can deliver. $10,000. That's not a typo. That's Tesla's actual target price for the Model 2, and it's already being built at 3,000 cars per day. 7 new updates are baked in: Porsche-inspired handling, Falcon wing doors, gigacast frames that solved a 3-year vibration problem, and production tech so advanced it's outpacing Ford and GM combined. But here's the shocking part. How does a $10,000 EV get features that cost twice as much on competitors? And why is Tesla's line running 150% faster than anyone else's? The answers reveal a manufacturing breakthrough that's about to reshape the entire industry. Let's dive right in. Here's what should be impossible. A $10,575 car that handles like a Porsche 911 and looks like a Jaguar F-Type. Tesla didn't copy these legends. They reverse-engineered the feeling. They studied what makes a 911 grip corners with surgical precision and what gives an F-Type that confident glide. Then they scaled it down into a compact EV using what insiders call scaled dynamics. The numbers tell the real story. Tesla targeted 10 to 15% lower rotational inertia than competing compact EVs. That means sharper steering response without the twitchy nervousness that makes budget cars feel cheap. Weight distribution sits at 48 to 50.